What does it take to be morally responsible for one's actions? In this set of videos, we're looking at the thesis that moral responsibility requires free will. Is that true? In the first video, we discussed the basic argument that there's no such thing as moral responsibility. It went as follows. Premise 1, moral responsibility requires free will. Premise 2, there's no such thing as free will. Therefore, there's no such thing as moral responsibility. The argument form is valid, meaning that if both of the premises are true, logic demands that we accept the conclusion is true. I'm assuming that the second premise is true. There are places in which that premise can be argued, but they're not our concern here. We're going to focus on the first premise, the premise that says that moral responsibility requires free will. That premise, the premise that says that moral responsibility requires free will, has a supporting argument. The first premise in that supporting argument begins with the fact that human actions involve the motion of matter through space and time. This movement can be caused by the determined forces of nature, the randomness of quantum mechanics, or the effect of a free will. The problem is that neither the determined forces of nature nor randomness can make somebody responsible for a wrongdoing. Or so it seems. So either free will exists to be the source of moral responsibility, or free will does not exist and moral responsibility doesn't have a source. In this video, I want to look at an argument that questions the claim that moral responsibility is incompatible with the determined laws of nature. This is an argument that assumes that there's no such thing as free will, but will argue that moral responsibility still makes sense. In the second video in this series, we looked at a paper from Peter Strawson that gave us a set of observations we can use to question this premise. Strawson noted that we tend to have two different types of reactions to things that happen that benefit or harm us. One type of reaction to the harms and benefits that come to us is a type that Strawson calls the objective attitudes. The objective attitude is the attitude we have when benefits or harms come from the forces of nature, and even the behavior of humans, such as very young children or those suffering from a mental illness. We may be happy or sad about such a state, but there's nothing like moral praise or condemnation involved. There's no anger, there's no gratitude. The other type of attitudes, what Strawson called the participant attitudes, included attitudes like anger or gratitude. These are attitudes that fill the relationships we have with friends and family, and others that we consider competent to make moral judgments. These two types of attitudes appear to be triggered by two different types of causes. If a harm or benefit comes from the intentional acts of a deliberative agent, whether a stranger or a friend, or an enemy, we have the participant attitude, such as anger or gratitude. When harms or benefits come from forces that do not use a process of deliberation, a nice warm sunny day versus thunder and lightning, we have what Strawson calls objective reactions. Reactions such as resentment and gratitude would be misplaced against the forces of nature. Note that these two different attitudes are reactions to two different types of causes. Can we make sense of having these two types of reactions to these two types of causes without saying that participant attitudes require a belief in free will? Well, yes, we can. Animals have two different types of reactions to two different types of causes. It seems absurd to say that they have a belief in free will. If we could understand the use of these attitudes in animals, perhaps we can see why humans have these attitudes, and we can come to see that a belief in free will is not all that important. In the first video in this series, I showed how it's possible for a computer program to consider and evaluate options and choose the option with the highest value. Now imagine a program to play chess that looped through the full set of pieces. For each piece, it then looped through all of the legal moves. It looked for the propositions that would be made or kept true by that move. Then it referenced a table that stored a value for the truth of each of those propositions. Taking the opponent's queen, for example, might be given the value of 9. The program computed the value of each move, then it selected the move with the highest value. We have here a program that considers a set of options, evaluates states of affairs made true or false by each option, and then selects the option with the highest value. All of this takes place in a system that has no free will. For what we're going to do next, a chess-playing program is a poor place on which to model the participatory and objective attitudes. The first problem is that it's a competitive zero-sum game. Any move that results in a benefit to one player produces a loss or harm to another. There are no opportunities for mutually beneficial actions, or mutually destructive actions for that matter. The second problem is that chess is a head-to-head two-player game. A better option for modeling objective and participant attitudes would be a multiplayer game, perhaps a game with hundreds or thousands of players. These players have opportunities to help each other, or to hinder each other. The third problem is that chess has victory conditions. Lives where the reactive attitudes developed have no victory conditions. For our model, we need a game where people play without trying to win. For our purposes, we need an open-ended game with no victory conditions, where players simply assess moves and make moves according to their values, where they share a board with perhaps hundreds of other players, and on which their actions have the potential to create states having either positive or negative value to other players. Now, the method of player choice at this game is still the same as it was before. The player considers a range of possible moves, looks at the propositions that would be made or kept true by that move, then reads the value of those propositions being true off of a table that we might call a desire table. We can see in this game that players can change the behavior of other players by changing the set of propositions that will be made or kept true, depending on how the other player moves. For example, this allows us to include in our program an option for one player to say to another, if you do anything like that for some action, then I will make false some proposition that you value highly. To keep that proposition true, don't do things like that. This would be a threat, deterring other players from making moves of the type that would trigger this response. Promising to make true a proposition the other player values would count as offering an incentive. This system of deterrence and incentives would be quite useful to the players in the game, and a programmer can easily program the avatars in this game to engage in this type of exchange. Now, in addition to this, our programmer can give each player the ability to alter the values in the desired tables of the other players. This will have the effect of making certain options appear more valuable to other players and other options less valuable. To fit this in our discussion, the program contains a bit of code whereby one player produces a benefit for another player. That player then responds with behavior that we call a display of gratitude. This in turn results in increasing the value of performing acts of that type in the desire table of the first player. This will make the first player want to perform those types of beneficial acts in the future. In cases where a player benefits somebody else, other players can respond with something like praise to increase the value of performing those types of acts. If one player performs an action that harms another player, the second player can respond with behavior that can be interpreted as anger. And third parties can respond with condemnation, where condemnation functions to attach a negative value in the desired table to perform acts of that type. This provides an illustration of a system that has reactive attitudes of anger and gratitude, and practices of praise and condemnation, without introducing anything at all like free will or an assumption of free will. Now, this is a mere illustration of a possibility. It's not meant to be a description of actual affairs, and as a description, it would be woefully incomplete anyway. Within this illustration, reactive attitudes of anger and gratitude only make sense as a reaction to behavior that is a consequence of the values in the desire tables of other players. These reactions make sense since anger and gratitude has the effect of altering those values, which in turn changes future behavior. If our game also has random natural disasters, it would not make sense to react to a natural disaster with anger or gratitude, since anger and gratitude has no influence over whether a natural disaster will occur. This illustrates how two different types of reactive attitudes, participant attitudes to acts brought about by deliberation, and objective attitudes to events that involve no deliberation, can make sense. We can apply what this computer program tells us to animals. Animals have evolved dispositions to react to behavior of other animals in ways that alter the values of other animals, in ways that are useful to that creature. These reactions of gratitude and anger make useful behavior more common and harmful behavior less common. Even plants do this. Some mushrooms cause nausea. The nausea creates in the animal an aversion to eating around anything that has that mushroom's look or smell. The animal doesn't avoid eating the mushrooms as a means to avoid nausea. This would require that the animal remember the past event and have the cognitive capacity to link the eating of the mushroom to the nausea. A much simpler system is for the animal simply to find the sight or smell of that type of mushroom repulsive. Peppers are interesting. Their seeds are destroyed by the digestive system of mammals, but not by the digestive system of birds. So they have evolved a chemical defense that causes pain to mammals, giving mammals a reason not to eat them, but that doesn't cause pain to birds. Birds can then eat them and spread their seeds. The point of this being that if fungi and plants can evolve to produce chemicals that alter the behavior of others in ways that are beneficial to the species, there's nothing unreasonable to suggest that mammals evolved reactive attitudes that function to alter the behavior of other animals in ways that are also beneficial. Also note that plants clearly don't use these defensive mechanisms as a means to realizing these benefits. The benefits are an unintended side effect that nonetheless helps to explain how and why the plant acquired that defensive mechanism. Similarly, animals don't employ these reactive attitudes as a means to obtaining some future benefits. The reactive attitudes are ends in themselves. What triggers the reaction is the fact that another creature engaged in a certain type of behavior. The benefits are unintended consequence that nonetheless helps to explain how and why animals acquired dispositions to have these reactive attitudes. So we have here an account of Strawson's reactive attitudes that's fully compatible with determinism. If a harm or benefit comes through processes that employ the values that others attach to certain ends, participatory reactions work to alter those values in ways that tend to, unintentionally, promote behavior that's useful and inhibit behavior that's harmful. If a harm or benefit comes through strictly natural processes, the reactive attitudes would be, for want of a better word, inefficient. We use the objective attitudes when harms or benefits come from causes we can't influence using the reactive attitudes. So what's next? I'd like to consider again the argument that moral responsibility requires free will. I'll be looking at a paper that was written by Peter Strawson's son, Galen Strawson.